Welcome to This Explainer. Okay, let's talk about time travel. For centuries, we've watched the science fiction movies, right? Someone jumps in a glowing car, hits 88 miles per hour, and boom, they're rewriting history. But today, we're going to separate that Hollywood fantasy from actual, rigorous modern physics. So is time travel just a fun thought experiment, or could it genuinely become reality? Let's find out.
So let me pose that ultimate sci-fi question directly to you. Can humans really travel through time? Now, if you ask most people on the street, they'd probably laugh and say, no way. But the truth behind one of science's biggest mysteries is actually a really surprising yes, but. According to modern physics, time travel is partly possible. However, the type of time travel we usually imagine, stepping into a glowing box in your garage, well, that's far beyond our current tech.
Okay, let's dive into this. To really wrap our heads around what scientists mean, we have to split the concept of time travel right down the middle. In physics, moving through time is broken down into two completely different realities. On one side, we have traveling into the future, which is seeing events that literally haven't happened yet. And on the flip side, we've got traveling into the past, visiting events that already happened. Scientifically speaking, these aren't just two sides of the same coin. They are governed by entirely different rules. Section 1. Journey into the future. The science of speed. And this is where things get genuinely triumphant, folks, because traveling into the future is already a scientifically accepted reality. To grasp this, we've got to look back at the absolute genius of Albert Einstein. His theory of relativity completely shattered our old understanding of how the universe works. Before Einstein, we kind of thought of time as this rigid, universal clock ticking away at the exact same pace for everyone, everywhere. But Einstein proved that time is not fixed. It's flexible. It actually bends, slowing down or speeding up depending on two massive factors, speed and gravity. This bending of time is known as time dilation. Now, what's really interesting about this is that it's the core scientific principle, where time changes its pace based on how fast an object is moving or the gravitational field it's in. This isn't just science fiction, guys. This is literally the key to future time travel. Let's walk through a visualization of how time dilation actually plays out. It's like a giant puzzle. Imagine we have two astronauts. Step 1. Astronaut A gets into a highly advanced spacecraft and travels out into space at a speed super close to the speed of light. Step 2. Astronaut B remains right here on Earth. Step 3. Astronaut A completes their journey and comes home. Because of their incredible speed, time literally slowed down for Astronaut A. They might have only aged a few years. But for Astronaut B back on Earth, where time kept moving at its normal everyday pace, decades could have passed. Astronaut A has effectively traveled into Earth's future. They're definitely going to need a whole new wardrobe. And if you're thinking, well, this is just some math equation written on a chalkboard, think again. Scientists have actually proven time dilation. We've observed this effect using extremely accurate atomic clocks, literally placing them on fast-moving jets and then comparing them to stationary clocks on the ground. The flying clocks literally ticks slower. We also see it all the time in observations of incredibly fast-moving particles in accelerators. So the bottom line, technically, traveling into the future is entirely scientifically possible today. Pretty wild, right? Section 2. Traveling to the past, where science gets complicated. Now let's slow things down a bit because we're transitioning from the proven future into the highly theoretical past. So what about going backwards? We're stepping into the deeply mysterious shadows of physics now. Some theories suggest that traveling to the past might mathematically be possible through some extreme cosmic loopholes. And the two primary ideas scientists explore here are wormholes and rapidly rotating black holes. Let's look at the first theory. A wormhole is defined as a theoretical tunnel connecting two distant points in space and time. Think of it like taking a piece of paper, drawing two dots on opposite ends, and then folding it in half so those dots touch, rather than drawing a long line between them. If a wormhole could be created and controlled, it might theoretically allow you to step through and emerge in the past. But, and this is a massive caveat, scientists have never actually discovered a usable wormhole. The second mathematical loophole involves rotating black holes. Some solutions out there suggest the rapid spin creates unusual paths through spacetime. However, trying to use a black hole to time travel would be a terrifying, absolutely deadly endeavor. Getting anywhere near one exposes you to enormous gravitational forces that would literally tear you apart. Not to mention the extreme radiation. And, of course, the fundamental nature of a black hole means you likely wouldn't be able to escape anyway. Section 3. The biggest scientific barriers. Why we don't have a time machine yet.
So you gotta wonder, if the math exists, why aren't we time hopping right now? Let's talk about the insurmountable physical hurdles. The very first barrier on our list is energy. Traveling through time, particularly punching a hole through space-time or accelerating massive objects near light speed, would require an unimaginable amount of energy. Some theories suggest we would need energy levels far beyond anything humanity can currently produce or honestly even harness. Next up is the logistical nightmare of managing a wormhole. Even if they exist, theories suggest they are highly unstable. To actually use one as a time machine, scientists would need a way to do three nearly impossible things. First, artificially create the tunnel. Second, keep it open because natural wormholes might collapse instantly. And third, accurately control exactly where and when the tunnel connects. Currently, that's all entirely theoretical. So the crucial point is how we actually accomplish step 2, keeping that wormhole open. Some theories require something called exotic matter. This is a strange, undiscovered type of matter with really unusual properties, like negative energy. We literally lack the physical materials in the known universe to build or stabilize this kind of cosmic doorway. Scientists just haven't found enough, or actually any, of this material to construct a machine. But beyond engineering, we face a fundamental logic puzzle that completely stumps physicists. Barrier 4, the paradox problem. When you talk about traveling into the past, reality itself starts to break down, and this brilliantly illustrates just how messy things get. The most famous example is the grandfather paradox. Imagine you build a time machine, travel into the past, and accidentally, or purposefully, no judgment, prevent your grandfather from ever meeting your grandmother. Because they never meet, your parent is never born, which means you are never born. But wait, if you were never born, how on earth did you build a time machine and travel back in time to stop them in the first place? It's an endless loop. It creates a major, perhaps insurmountable problem for scientists trying to prove past time travel is possible. Section 4, the final verdict, where we stand today. Let's bring all these threads together. Let's look at the final verdict on exactly what the science says right now. The contrast is really stark. For future time travel, the status is clear. It is scientifically possible according to physics. As our spacecraft technology improves and we can travel faster, stepping into the future will become a much more pronounced reality. But for past time travel, there is zero concrete evidence that it can actually happen without completely breaking our current understanding of the universe. And as for a real, functioning time machine, no technology currently exists to make one. Building a machine that allows humans to freely travel back and forth through history remains one of the absolute greatest challenges in all of science. But remember, 100 years ago, even the idea of time dilation seemed impossible. Maybe one day, future generations will uncover secrets of the universe that make today's impossible ideas tomorrow's reality. I want to leave you with this thought. The question is not only can we travel through time, but how much more do we need to learn about time itself? Thank you so much for joining me on this explainer. Keep questioning the universe and keep learning.